but I can definitely. And how Terraform rolls out the changes is with a push-based approach. That means we run a Terraform command, which will then make the relevant changes based on your configuration file. The cool thing about Terraform is that we don't need to install an agent on the remote machine that needs to make those changes. We can simply run the Terraform command, and then Terraform will communicate with your cloud provider to make those changes happen. So how does this happen? In fact, the Terraform command knows how to make API calls to your cloud provider. As you might know, AWS and GCP and Azure, they usually expose an API that we can use to manage infrastructure in those cloud environments. And Terraform uses those APIs, so it makes HTTP calls to those API endpoints to say, well, create an EC2 instance, make those changes, and so on. And here's also where a specific term already comes into play, a provider. So the provider is a concept that we have in Terraform that lets us communicate with those APIs. And obviously between those cloud providers, there's a difference in what the endpoints look like. They're not uniform, but a provider in Terraform knows how to communicate with the cloud provider and makes this abstraction for us. So we don't have to understand how to communicate with an API exposed by AWS or GCP or Azure. That is the purpose of a specific provider. It will also handle authentication if that's required. Usually it is required. And then in Terraform, we call the configuration the instructions that we want to run against the API that make the relevant change on the cloud provider. So keep those terms in mind, provider and configuration. They will show up in many of the following slides as well. Just to put this into perspective, how this looks like. So if we have the Terraform binary installed, potentially you already have that, but we'll definitely do that on our end as part of this training as well. We will read the relevant configuration for Terraform. That will define how the desired state should look like. And then Terraform will make those API calls to the cloud providers. You can see here we can make changes to different cloud providers, AWS, Google Cloud, Azure. There are also some other environments that we can call that we're not going to discuss, but for the most part, that is the most common use case here. So as I mentioned before, there's not really portability between those cloud providers, I would say. So you cannot use the same configuration code that we've written for AWS and then simply say, do the same thing on Google Cloud, simply because the cloud providers don't necessarily provide the same kind of infrastructure all the way. So the EC2 instance terminology and what this means in AWS doesn't really exist in some of the other providers. They call it something else. Optimally, you would have probably, if you wanted to switch from one cloud provider to a different one, you can. However, your configuration code would simply look different. And a matter of fact is that the Terraform language allows us to make a switch fairly easily, again, with the help of reusable functionality. And therefore, the switch is somewhat easy. Nevertheless, you have to adapt to how this should look like on a different cloud provider. So let's talk about some of the Terraform components here. So first of all, we have the executable. That's the command line tool that we want to install on our machine. It's freely available, it's open source, and that's what we're going to do in the first exercise. It provides the basic Terraform core functionality. Then we have the configuration, which lives in so-called configuration files. Those are the files that are meant to be checked into version control.
And those files, based on the conventions that Terraform has, have the file extension .tf or .tfvars. So we'll talk about those in more detail, but those are the most common extensions. There are some extensions for JSON files as well, but given that this is somewhat more a legacy kind of implementation or configuration file format, we're not going to discuss them in more detail, but those are the configuration files. And then coming back to the term of a provider, there are plugins for providers. They're also called providers in the terminology of Terraform. That will know exactly how to communicate with these APIs that we want to make a call to make relevant changes for the infrastructure. So provider plugins know how to communicate, know how to authenticate, and those are usually hosted on a registry. So all we have to tell Terraform is use a provider for, say, AWS, and Terraform will know exactly how to retrieve that provider based on the version that you provide for the plugin. And then it knows how to interact with the cloud provider in more detail. And then one thing that we'll drill into more is the state data. That is a representation of what should happen in the actual infrastructure versus what we defined as the current state. So the current state is basically what exists in the cloud provider. What do we have created? What did we create already in the infrastructure? For example, on AWS, that's the current state. And then what do we want to happen? That is defined by the configuration files. That's the desired state. And the state data will know the difference. It will know the delta between those two different environments. So persisting state, Terraform will know what needs to be created. So if we get started by saying, hey, we want to have a AWS instance, and this is one example here for a AWS instance in the form of a HCL configuration. You don't necessarily need to understand this all, but you can probably understand what it means on a high level. We want to create 2 AWS instances. Those are EC2 instances in the form of AWS terminology. We want to use a specific base AMI that knows how to run this EC2 instance. And then we want to define the type. So how much hardware do we want to grant to this specific instance? So all we have to say in Terraform is make those changes. So Terraform will look at the configuration in your configuration file and then create those instances that we want to have. So down here, that's the desired state. And up here, we have the current state. If we were to change the configuration, let's say we wanted to create 3 different instances, we simply say make the changes in the configuration file, assign the value 3, and then if you run the apply command again in Terraform, it will actually make those relevant changes in AWS automatically for us. And as you can see here, we don't have to know anything about how Terraform communicates with AWS. That's completely abstracted. You will see that we need to provide authentication credentials, but that's something that we'll look into in a little bit. But ultimately, we're just dealing with a declarative language. In this case, that is HCL, which we say how the environment should look like. And then we run a Terraform command to actually make those changes. Let's briefly talk about where we store the state that I mentioned before. So the state data is stored in a local file usually. And each resource that we define in the configuration file is available in that database. So I call it an internal database. Ultimately, if you're looking at a local state file,
This is just represented as a JSON structure. You can see that this is marked down with all the configuration that is required, and that is effectively the desired state. And then if you want to have a look at it, you can. All you need to look at is the terraform.tf state file, which lives in the same directory as you run the files, as you run your Terraform commands from. So we'll have a look at the state in a little bit and how this looks like. Usually you don't have to have a look at the contents of the file. This is more for the purpose of actually storing the desired configuration, so it can make the relevant calls to the cloud provider. There does exist a way to configure Terraform to store the state on a remote machine in a remote environment. That is pretty much where Terraform Cloud comes into play. So imagine you are working with 10 different people on the same infrastructure, and all of those people have their own local state file. Obviously, this state file is not shareable, so therefore there could be potential conflicts between those different people that work on the infrastructure. And therefore, it's a much better choice to handle the state on the remote machine. For that purpose, you would likely use Terraform Cloud, but it's not massively a focus of the certification program. We'll talk about it later when we talk about Terraform Cloud and how it compares to the CLI tool in more detail. But we'll definitely not try out Terraform Cloud in this training today. And as you can envision, there are a couple of benefits to the state as I've shown to you. So first of all, it knows exactly what resources need to be created and what the dependencies between each other are. So for example, we want to create a database on AWS, but it requires an EC2 instance beforehand. In those cases, we can create those dependencies between each other. In fact, for the most part, they are implicit anyway, but we can also define what the order should be explicitly in our configuration file. Given that we're keeping the state of the desired state and the current state, Terraform will know exactly what needs to change. So performance is a big part of it. We're never just deleting everything that exists on the remote in the cloud provider. What Terraform will do, it will try to determine the delta, so the change between the desired state and the current state, and then we'll only make those relevant changes. And one side effect of that is performance. We don't have to wait for forever to let Terraform make those changes. It will know exactly what needs to be changed. And then obviously consistency. We want to make sure that if multiple people work on this, we're not running into any kind of synchronization issues. If, say, we have 3 different people trying to make different changes to the cloud environment, then we don't want to override each other's changes necessarily or bring the environment into an inconsistent state. And with the help of Terraform, we can make sure that this actually will happen. All right, so that is the theoretical part of this portion. And I can see there are plenty of other questions. So let me just answer questions that are not relevant to any other tooling outside of Terraform. Here's one question. What is the best exam practice site that is very near to the actual questions? So I would say have a look at one of those here. Those are pretty good. I did like the Udemy one. So if you look at this one, it has a bunch of practice exams, each of which have 57 questions. So if you buy the full set of practice exams for $20, you get like 5 practice exams, and this will get you pretty far, I think. So you can practice quite a bit with that. So that's a good start. You will also see that the Wiz Labs will contain some additional practice exams or practice tests, in fact, 4 as well. But it comes with a video as well, so depending on whether you want to buy both of them is up to you, but those are pretty close to what I would say are a good preparation for the course. Let's see what else we got here. Here's an additional question about something that comes up pretty soon. Somebody's asking about the .terraform directory. So I'm going to put this on the back burner. We will talk about that anyway. But in short, in a nutshell, the .terraform directory is the directory which Terraform will use to download the provider plugins to. So when you say, I want to use AWS, and you configure the provider for AWS, it will download the relevant implementation to this directory. So therefore, it will be cached. Following calls to Terraform will not need to download this implementation over and over again. It can basically reuse it. And all the other questions I will try to answer as we go along. They basically go beyond the scope of the Terraform certification. But I will definitely answer them. Right now, there are plenty of them, so hold on tight. I will try to answer them as we go along. Just need some additional time to answer those questions. If not 20, that I will try to answer. And in the meantime, we can get everybody else. Of the other commands, not all of them, only the ones that are relevant to the actual exam. And then in terms of the AWS account, you've seen that I already created an instance of my account, not really a EC2 instance. That's not what I meant here. I created an account on AWS, which is already running, and I got my security credentials from here. So if you wanted to get them, I already exported them as environment variables, but it will also show you how you could potentially read them from the AWS configuration file. And then in terms of the IDE, that's what I got here, VS Code with the right extension. So if I look for the extensions here, I think it's probably under here, extensions. And there should be an option for Terraform in any kind of form. HashiCorp Terraform right here. So I already got that configured. So if you wanted to follow along in the IDE, that's how you can do it. Somebody's asking about version 1.2.3. That should be fine. Obviously, versions change over time, and sooner or later, those versions will be updated. I don't think there will be a big difference between 1.2.2 and 1.2.3. They probably just fixed the bug in that because it usually follows